So first, let's talk about descriptive versus inferential statistics, which are the two major classes of statistics. Descriptive statistics summarize aspects of samples or populations, so they describe things. Now, what's population? Begs the question. It's all members of a group that have some common characteristic of interest. So, for example, all homeless persons. So a sample is a subset of that population that shares that same characteristic of interest, but it's a subset, like the picture shows. Now, we do research almost exclusively with samples because, well, not only do we really have access to entire populations, we don't have all day, right? We got other things to do in this, besides just research on one study. So whether something is considered a sample or population really depends on your perspective. So this class, for example, is the population of my statistics course, but a sample of all graduate students. Inferential statistics, the other major class, are used to make generalizations or inferences about a population from a sample. So you calculate sample statistics and whatnot to try to make a guess of what's going on in the population. So a little bit about generalizability is important for sampling. Choosing a good sample affects your external validity, which we talk about later on today. External validity is your ability to generalize your findings outside of your sample. So the extent to which you can generalize your findings to other people, places, times, settings, etc., variations in procedure. So it should kind of be obvious, but you can only generalize results to the population from which you sample. So findings on a survey of middle-class people may not reflect the views of rich people. Common sense, but you see it all the time where they're generalizing findings from some subgroup to a larger group. So if you don't choose a sample that's representative of the full population you want to describe or generalize to, you can't infer conclusions to that population based on your study, right? So for basic sort of biological things, it might not matter. So like everyone, if you blow air at their eye, will blink, or you smack their knee, they'll kick, that sort of thing. But other times you don't care because you just want to demonstrate the effect of whatever, using whatever sample you can get to, and you'll just leave replication to others in the future, like your dissertation. Like you're just going to hopefully get who you can and graduate, and not worry about the extent to which things externally generalize. However, for other things like opinion research, that is meant to represent the larger population, choosing your sample, you have to consider its representativeness. It's very important. So the two sort of major ways of thinking about a sample is it representative or biased? Representative samples, the sample does adequately represent the population of interest. In biased samples, the sample does not adequately reflect the population, right? So in some way, it doesn't reflect the whole population. It's biased. So it goes without saying, but it's worth saying that a large crappy sample is not as good as a medium-sized good one. Okay. So for example, in the Dewey versus Truman poll of the 1948 presidential election, this newspaper did mistakenly proclaim Dewey as the winner over Truman. Well, you've never heard of a President Dewey, but there was definitely a President Truman. So something went wrong with the survey. Specifically, they chose persons for their sample from phone books and vehicle registration records. But, back in the day, a large proportion of the population had no phone or car, so the sample was biased towards people with higher income, leading to the wrong conclusion about popular opinion. So there were two major types of sampling strategies. That is how you pick a sample from the population. There are probability sampling methods, and that's when you use random selection to choose a sample that's representative of the population to avoid bias. If you do it randomly and you get a big enough sample, you'll end up with a sample that is representative of the population. So, and unbiased. If the other major type is non-probability sampling, and that's when you do something other than random selection. So you don't use a random method to choose a population. So there's no guarantee that it's going to be unbiased. That is, there's no guarantee it's going to be representative of the larger population. There's something just magic about randomly selecting folks that results in better samples. So just because a non-probability sample is large doesn't magically make it unbiased. So again, it's better to have a medium-sized representative sample, particularly for things like opinion research, than have a huge, not necessarily representative one. So let's talk about some of the probability sampling methods. These would be the ones you wanted to use if you wanted to generalize opinion research, things to a whole big population, etc. There is, from the get-go, the most simple is just true random sampling. And this is when every person in the population, so everyone who has the potential of being in your study, has an equal and independent chance of being selected into your sample. So for example, let's say you're going to do a survey of Alliance students. One way to get a true random sample, which is the most basic type of probability sample, is to get a listing of all students from the registrar, or all the registrars, number them from 1 to whatever n, and then use a random number generator to randomly select persons until you get a sample size that you need. That would be a true random sample. Every person has an equal and independent chance. So the independent means if one person is selected, it does not change the probability of any other person in the population being selected. A counterexample of that would be you randomly select a house, and in the house, anyone who's in the house is selected to be in your sample. That would not be true random sampling because the other people's probability of being in your sample is increased by having a family member complete the survey. Then there's stratified random sampling. So this is when you identify subgroups in the population and you randomly sample from these groups to get the same proportions in your sample as there are in the population. So what does that mean? Let's say you know that there's 60% women, 40% men at Alliance. So the first thing you would do to make sure you get these strata represented equally 60-40 in your sample would be to divide that registrar list into men and women, and then you would sample 60% women, 40% men at Alliance. And that would ensure that you have the same sex representation in your sample as is in the population. So that's called stratified random sampling. The important point though here is you divide it and you randomly select folks from the men and the women. So continuing with probability sampling methods, there's also systematic random sampling. So systematic random sampling is when you randomly select a starting place to start choosing participants, and then you use some sort of rule from there on to to select from there. So for example, let's say you were picking your students again from Alliance, and you number the students on the list, and let's say there's 1 to 2,500. You have a random number generator, choose a starting place, let's say it picks person 171. You start there, that person's in your sample, and then you use a rule. Every 50th person after this random start person is going to be in my sample until you get the sample size you want. And that is starting at a random place and then using a systematic rule is called systematic random sampling. There's also multi-stage random cluster sampling. So this is when your final sample is chosen through a series of random selection decisions. So that are used to eliminate potential participants. So you go through multiple stages, each one random, to arrive at your final sample. What the heck does this mean? Let's say you wanted to choose Alliance students again, but you started with different degree programs. You randomly choose 3 programs, and then from the class listings for each of the programs, you randomly choose 2 classes. Then from the classes, you randomly choose students until you have the sample size you want. So there's 3 stages here: program, class, student. Each stage is random. That makes it a multi-stage, multiple stage random cluster sample. So those were our probability sampling methods, and chances are you're not using any of them for your dissertation. They're more likely to result in a sample that you can generalize more broadly, but you're just trying to get out of school, right? So it's okay. You're probably going to use one of these. So let's start with the most basic non-probability sampling methods. This is when you don't use random selection to choose your sample. So the first one is convenient samples. You just choose a sample based on convenient access. So who do I have access to? My Facebook group, boom. Or I use this class to do a survey. Or I stand in front of a grocery store and I just ask everyone who walks out to do my survey. Any of those are just convenient samples. They're samples of convenience. Purposive sampling is when you want to study a particular subgroup, and you form your sample by including any available people you could find who meet your specific criteria. Again, not randomly, you're just trying to enroll people. So for example, let's say you want to do research on people who have trichotillomania. You just try to find people. So like you advertise at treatment centers, Reddit groups, Facebook, etc. And anyone who's willing to do your questionnaire, you let them in your sample. That is purposive sampling. It differs from convenient sampling in that they have to meet specific criteria. Then there's snowball sampling. So snowball sampling is also used when you're studying something that's sort of hard to find people again. So the sample is formed by starting with a purposive sample. So you find people who have the condition of interest or whatever it be. And then you include persons referred by those participants. So for example, if you were doing a study on folks who'd been in federal prison, you purposively go out and try to find folks who've been in federal prison, and then you say, hey, can you send this survey to other folks that you know? Or the example I got here is about you want to do your research on trichotillomania. You know, they have support groups and they talk to each other and those sorts of things. And so maybe what you do is you find people in a purposive way, and then you have them refer other persons they know who have trichotillomania to be in your study. You'd be doing what's called snowball sampling. So quota sampling is frequently sort of confused with stratified sampling, but this is when individuals of specified groups are added to your sample until a pre-specified number is met. It's not done randomly. So you're trying to get, 50 women, 50 men, and you just stand in front of the grocery store, so it's not random in any way, and you ask people to take your survey until you got 50 women and 50 men. But how does this differ from stratified sampling? Well, if men came up while you were trying to get women because you already had enough men, you would say nope. You wouldn't ask them to do your survey. Okay, so you actually, once your quota is met, you're done. Whereas with stratified sampling, you're trying to get that proportion more naturally by enrolling people. So then there's systematic non-random sampling. So this is when the sample is selected through a systematic but not random process. So again, you start at a place but not a random place, and then you use a rule to pick people. So for example, you stand in front of the grocery store and you ask every 10th person who comes by to take your survey. You didn't start at a random place, but you still followed some sort of systematic rule, so that makes it systematic non-random sampling. It's not as good as systematic random sampling, but it works. There's also stratified non-random sampling, and this is when sample is selected to have some specified ratio for each target group, again, but not randomly. So you want a 60-40 female ratio in your sample. You ask people who walk by in front of the grocery store to do your survey, and ask more men or women as necessary until you get that 60-40 ratio in your final sample, but you're not turning people away. That's how it differs from quota sampling. Quota, just think once they get their number, they're done with that group. Here you keep enrolling until you get that 60-40. There's also multi-stage non-random cluster sampling. So it's just like that multi-stage one before where we're talking about Alliant programs, classes, and then people. Same sort of process, but not random. That's basically it. So let's say to choose those Alliant students, I start with different programs, but I choose 3 where I know the program coordinator, and they're more likely to help me, right? And then from the class listings for each program, I choose 2 classes where I know the professor maybe, or where the professor is recommended to me because they're going to be cool and help me do my study. And then from the classes, I say, hey, who wants extra credit? And I choose students who want extra credit to be in my study. So there's multiple stages to arrive at that final sample. But it's not done in a way that is random, right? I'm just picking things conveniently in this case. So there's also special samples when you've got age or time as the independent variable. Cross-sectional sampling, and you've no doubt heard of cross-sectional studies. This is when stratified samples are selected from designated age groups at the same point in time, so you can look at the effect of age. So same point in time, you're selecting different age groups, so you can compare them. So let's say I wanted to study the habits of different age groups, and I select a group of people in their teens, a group in their 20s, 30s, 40s, 50s, and I have them do my survey. So it's one point in time I'm comparing different people from different age groups. So I can compare them. That's called a cross-sectional sample. Longitudinal sample is when a single sample of participants is measured repeatedly over time, so you can look at both the effect of age and time at the same time. Oh gosh, too many times in there. But you follow the same people in the longitudinal sample is a way to think of it. So for that same study, let's say I select people when they're teens, and then I have them do my survey, and then I have these same people repeat that survey every 5 years. So instead of one time getting teens, 20s, 30s, 40s, I'm taking them out every 5 years and having them, the same group, do my survey. That would be a longitudinal sample. So there's also trend sampling. So this is when repeated samples of the same population are measured over time, so the effect of time can be measured. So let's say I want to look at differences in driving habits of teens. So I select a group of 16 to 17-year-olds every 5 years and give them a survey, right? So they're different 16 to 17-year-olds, but it is the same sort of age cohort or group, and I'm just following them over, I'm looking at trends in that group over time, right? So the key here being it's different folks who have this characteristic of being 16 to 17 years old over time. Cohort sampling is when some subset of the population is repeatedly sampled over time, so the effect of time can be examined among that subset. So up top, it was different 16 to 17-year-olds. Cohorts can be folks from the same cohort, right? Repeatedly measured over time. So for example, I could have different samples of Gen X's complete a survey every 5 years. So they're different Gen X people, but I'm looking at changes in how Gen X generation views things over time, that sort of thing. So let's try to apply this. Name the sampling strategy. Be as specific as possible. A team randomly selects homes for a door-to-door survey by picking 4 neighborhoods, 6 blocks randomly in each neighborhood, and 3 homes randomly on each block. So you got multiple stages, and they're doing it randomly. What's that called? Multi-stage random sampling. The same children who were first measured on diet in 1980 are re-examined in 1990, 2000, 2010, 2020, etc. Follow those same children over time. What kind of study is that, where you repeatedly measure the same sample? That is longitudinal sampling. Participants for a study at a university are randomly selected from each of its 3 schools, with the representation proportional to the enrollment in the 3 schools out of the entire district. So there's strata in here, right, where they're trying to get representativeness of those strata. It's done randomly. What's this going to be called? Stratified random sampling. A university administers a battery of personality tests to each year's incoming doctoral students to examine changes in the students' characteristics. All right, so it's kind of like they're a group but different people in this group are being measured each year over time. Trend sampling. A computer randomly picks 100 people from a list of all registered voters in the community. This one is the most simple type of random way of picking. True random sample. An Alzheimer's researcher gives a packet of questionnaires to volunteers at a local senior citizen center who may or may not have Alzheimer's. All right, so they want to do Alzheimer's research, but they may not have Alzheimer's. This seems to me like it's not really the one where they're getting just Alzheimer's people. It is a convenience sample. They're just giving it to whoever they can and hoping they get enough people. A sample is structured to include the first 12 men and first 12 women who volunteer at a PTA meeting. Doesn't that sound like they're trying to get exact numbers, like a quota? Quota sampling. Doctors refer parents of newborn deaf infants to researchers for their study on infant deafness. So here we've got folks who are, the babies have a specific criteria, right? So you're purposely going out to get deaf infants. Purposive sampling. The third caller to a radio talk show and every 10th caller thereafter are included in the sample. That third caller was picked through a random process. We use some rule. We start at a random place. Systematic random sampling. All right, finally, hopefully this is starting to make sense. Japanese researchers annually examine the health records of samples of people born in 1945. Different samples are studied each year. So you've got an age cohort that's different people are being sampled, so it's not the one where they follow the same group over time. What's this called? Cohort sampling. The physical development of groups of 10, 20, and 30-year-olds is compared at one time. So different age cohorts at one time. What's this one? I think it's the easiest. You're looking at cross age groups at one time. It is cross-sectional sampling. So that's it. Hopefully this sort of made sense. And if you have any questions, throw them up in the questions on Canvas and we'll get them answered. And otherwise, I hope this was helpful.